guys, so in our previous lessons we were looking at electron dot diagrams, we were looking at electronegativity, and we were looking at the shapes of molecules. So we're going to all put that together now and use that knowledge to give us an idea of the polarity of molecules. So polar molecules have a slight difference in charge, so some parts of the molecule are going to be a bit more positively charged compared to other bits which are going to be a bit more negatively charged. So polar molecules include ones such as hydrogen chloride and ammonia, because there's a difference in charge. So there's going to be a slight negative charge at the top here because of the lone pairs. Remember from before? There was a lone pair here, and that's why it pushed all this down, all the hydrogens down into the pyramidal shape. So a bond is formed between two atoms that differ greatly in electronegativity, such as lithium and fluoride, and that will form an ionic bond. So an ionic bond is represented here. So there's a strong tendency for an electron to be transferred completely, so it's not shared anymore, from the metallic element, so the lithium, to the non-metallic element, the fluorine. So in this case, the electron pair is not shared anymore. The lithium is giving up an electron and giving it completely to the fluorine. So this is an ionic bond. So ionic bond, if the difference between two bonded atoms in electronegativity is greater than 1.5, it's going to form an ionic bond. So non-polar covalent bonds are formed when there's two identical atoms, example, two chlorine atoms in Cl2. So the electrons are shared equally because they both have the same amount of pull. A polar covalent bond occurs when two different types of atoms form a covalent bond. So the electron pair is not shared equally between the two atoms because one is different from the other and it has a different amount of pull. The electron pair are attracted more closely to the electronegative atom. So remember, the electronegative atoms are the ones that have a higher pull for electrons towards it. So this was oxygen and fluorine usually. So in a polar covalent bond, these covalent bonds are those that there's an uneven distribution of charge. So that means one side is going to be more positive and one side is going to be more negative. So here's a summary of it. If we're going to have an ionic bond, there's going to be a large difference in attraction of electrons because the sodium is going to completely give an electron to the fluorine, which is denoted here. So the sodium is going to be positively charged because it lost the electron, and therefore it's no longer neutral, it's positive because it lost it. The fluorine here, it gained an extra electron, so it's going from a neutral to a negatively charged one. So in a polar covalent bond, we have two different atoms, hydrogen and fluorine. And remember before, fluorine is one of the most electronegative ones. So when it's getting a shared pair of electrons in a covalent bond, the fluorine is going to pull the electrons in closer compared to the hydrogen. And therefore this side of the molecule is going to be a little bit more negative than this side. But it's not going to be a full negative charge like in an ionic bond. And then in a pure covalent bond, where there's going to be no difference in charge, such as in this molecule, that means all the electrons are shared equally. So pretty much as you go up here, you're increasing the magnitude of bond polarity, with the maximum being an ionic bond and the minimum being a pure covalent bond. And as you go up here as well, you're increasing the difference in electronegativity of the atoms. So this is a very big difference between electronegativity, but a small difference here. So a pair of equal and opposite electric charge separated in a space is called a dipole. So polar molecules are molecules that have a net dipole. So what this means is that we're going to add up all the charges and then you're going to get the sum of them to give you an idea of which side is going to be more negative and which side is going to be more positive. So in this case it's water, and we have one dipole here, and then we're going to add them together, so then we know that this side is going to be more negative and this side is going to be more positive. In the HCl molecule, this chlorine atom is more electronegative. So on the table, as we saw before in a previous lesson, we saw that chlorine has the value of 3.2 and that the hydrogen one was 2.2. So because the more electronegative one is 3.2, higher number means more electronegative, the chlorine atom is going to have more pull because it's more electronegative. So it's pulling the electrons in closer to this side, and therefore it's going to have a slight negative charge on it. Whereas the hydrogen, because the electrons have now moved towards this way, is going to be slightly positive. So hydrogen chloride is a polar molecule. The bonding electrons are attracted to the chlorine atom because it's more electronegative, and the chlorine end of the molecule is going to be the negative, slightly negatively charged, denoted by this symbol. So the hydrogen end is going to be slightly positive with the positive symbol. So if you're going to put these molecules all in an electric field, so that means you're going to have one positive plate, one negative plate. All the molecules are going to align themselves based on the polarity because these molecules are polar. So if a polar molecule is placed in an electric field, it tends to align itself with the field. The positive end of the molecule is going to be orientated to the negative end of the negative plate because positive and negative attract. Similarly, the negative end is orientated towards the positive plate. So all of these are going to line up with the positive sides going that way and the negative sides coming this way. So in summary, we just looked at polarity of molecules, and this is because there's an uneven distribution of charge on the molecule, and it's made up of dipoles. So dipoles are going to add up together, give a net charge, so then we can then decide whether the whole molecule is going to be polar. If we place polar molecules in an electric field, they're going to align themselves in the electric field. So now that we know all this, we can answer some questions. So question 16. Predict which of the following bonds will be the most polar. Cl and an O, H and an N and an F. And then calculate the difference in electronegativity for each atom pair and explain your answer. So this question has a lot of multiple parts. So we need to first predict which of the following bonds are the most polar in those combinations. We also then have to calculate the difference in electronegativity using our table that we had before. And then we also have to explain our answer. So we need to make sure we answer all three parts. So firstly, for the chlorine and the oxygen. The chlorine here is in 3.2 and the O is 3.4. So 3.4 minus 3.2 gives us 0.2. For hydrogen and nitrogen. Hydrogen is 2.2, nitrogen is 3. We minus it. 3 minus 2.2 gives us 0.8. And finally, N and F. N is here, 3, and F is here, 4. So 4 minus 3 gives us 1. So first, we already calculated the difference in electronegativity for all of them. We can then predict, the first bit of the question, predict the following, which of the bonds is going to be the most polar. The difference in values gives us how much difference there is in electronegativity. And the bigger the number, the more polar it's going to be. So because this one is the highest number at 1, and this is the lowest number at 0.2, this one must be the most polar one. Finally, we need to explain our answer. And that's what we just did before. So when we have a large difference between electronegativity, that means there's going to be a very big difference in charge, and therefore we will have the most polar molecule. Question 17. How do the electric fields impact on polar molecules? So in an electric field, there's going to be two different plates, one a positive plate and a negative plate. So in an electric field, if we put a polar molecule in there, they're going to align themselves within the field. So the positive end of the molecule is going to be oriented towards the negative plate because opposites attract. And the negative end of the molecule is orientated to the positive plate because, again, opposites attract. Next, question 18. How do covalent polar molecules form? So when we have two different types of atoms, they form a covalent bond, and an electron pair is not shared equally between them because there's going to be electronegativity differences. So electron pair is going to be attracted to the more electronegative atom because they have the stronger pull. Covalent bonds in which there's an uneven charge distribution, so that means one side is going to be more positive than the other side, which is going to be more negative, they're going to have polar covalent bonds because it's polar because there's difference in charge. Question 19. What two conditions must be fulfilled for a molecule to be polar? So a polar bond is a covalent bond in which the shared pair of electrons are more likely to be nearer to the atom with the higher electronegativity because we said they have the greatest pull. So they're going to pull the electrons closer and therefore have a slight negative charge on it compared to the other one. So one end of the bond is going to be slightly more negative than the other, which is going to be then slightly more positive. And a polar molecule is one where the polarities of the bonds do not cancel each other out, and therefore there's asymmetry. So if it's not symmetrical, they can't cancel each other out, and that means we're going to have a distribution of charge over the whole molecule. So because there's asymmetry between the polar bonds, this makes one part of the molecule slightly more negative and the other one slightly more positive compared to the other side. So all in all the different polarities, polar bonds, are going to add up, and we're going to have a net charge over the whole molecule. Question 20. Is CF4 polar or non-polar, and explain with the aid of a diagram? So in this question, it's got two parts. The first bit is it polar or non-polar? We can just say either one. Second part, we need to make sure we explain with a diagram. So the CF bond is polar because it's got the very electronegative fluorine atom and the not so electronegative carbon atom. So because there's a carbon atom and 4 fluorine atoms, we know that it's going to be a tetrahedral shape because remember, we're going to put the carbon in the middle, and then we know there's 4 fluorine atoms around it. So to maximize the distance, remember we have to maximize the distance between electrons. So the maximum distance you're going to get between 4 sets of electrons is going to be a tetrahedral shape. So in a tetrahedral shape, they're all equally distant, and therefore it's not going to be a polar molecule because all of these are going to cancel out because there's lots of symmetry. So just to recap, we just talked about polarity in molecules, and that's the difference in charge over a whole molecule, and it's due to the sum of all the different polar bonds within the molecule. If there's going to be symmetry, then there's going to be a non-polar molecule. So polar molecules require A, electronegative atoms to cause a difference in charge over bonds, and B, there's going to be a need for asymmetry in the molecule.